Today, we will be talking about the last topic in Unit 1. Yes, we already took the Unit 1 test, but this topic was not on the test and it does go with Unit 1. So we're going to talk about it today and tomorrow before we start Unit 2. The topic is literal equations. Before we get too far into that, let's review real quick. We just did equations solving for variables. And the way we decided to solve those is we would ask ourselves, what is the inverse operation? To get this x by itself, we would say, well, how do I get rid of a minus 3? Well, the answer would be you would add 3 on both sides for this equation. Now, let me change this one up a little bit because it's also a subtraction problem. But what if this was an addition problem? Well, the inverse of addition would be to subtract 4 here and subtract 4 on the other side of the equal sign. I would be using inverse operations. This one's a little more complicated. I would need to move this 5 because it's a constant by adding 5 over here. I would need to move this 3x by minusing or subtracting 3x to this side. Then I would have to combine like terms and divide by a coefficient. So this one takes multiple steps. But in all three of them, in order to get started, we had to know the variable, in this case, x, in this case, x, in this one it was z, and we had to ask the inverse operation to isolate our variable. We're going to be using that same concept with our literal equations. So before we get too far into it, I need you to pause the video and write today's date with this title, Literal Equations, and the learning target that you should be able to do when you finish this video is to rearrange a literal equation to solve for a variable. So take a moment and write that down and then restart the video. Literal equations are equations with 2 or more variables. So far, we have only solved equations with 1 variable in it. You can rewrite a literal equation to isolate any one of the variables using inverse operations. This is called solving for a variable. Here's some examples of literal equations that you probably have heard of, but maybe nobody ever called them literal equations. Here's the first example, V equals LWH. That really stands for volume equals length times width times height. It really actually stands for something that you've probably heard of. Here's another example, D equals RT. This stands for distance equals rate times time, like that mile per hour question from your test. If you are going 30 miles per hour, which is your rate for 3 hours, 30 times 3 would give you your distance, which is D. So this is another equation where I have 3 variables, D and R and T, but it stands for something that we actually use. Here's a third example. It has 3 variables, P, L, and W. It stands for perimeter equals 2 times the length plus 2 times the width. In order to solve a literal equation, we have 3 steps. Step 1, locate the variable you are asked to solve for in the equation. Step 2, identify the operations on this variable and the order in which they are applied. Step 3, use inverse operations to undo operations and isolate the variable. Step 1 is really one step. You find the variable. Step 2, identify the operations. You're just looking and deciding what's going on in the problem. Step 3, when it says use inverse operations, step 3 may take you one step to finish. It might take you a couple of steps to finish step 3. Write these down. Pause if you need to. So here's the first example. Solve x plus y equals 15 for x. Solve x plus y equals 15 for x. This little part right here where it says 4x is actually telling me which variable I want to get alone for this problem. I want to get x alone. Notice it has two variables already in it, x and y. So step one is to locate the variable in the equation. So here it is, x is the variable that I want to get by itself. So I've located it. Step two is to identify the operations that are happening. The operation that's happening to x is that y is being added to it. So y is added to x. My third step is to undo that with the inverse operation. Since y is added to x, I'm going to subtract y from both sides to undo the addition. So I'm going to do just like I did in Unit 1. I'm going to separate on the equal sign, and I'm going to do the same thing on both sides. So I'm going to subtract y so that x will be by itself, and I'll have to subtract y on the other side of the equal sign. Now, just like we were doing the last couple of weeks, these two y's are going to cancel out, being a big 0. What's going to be left is x. On the other side of the equal sign, in the last couple of weeks, we were able to do something like we could have done 15 minus 5 and we would get 10. But we don't know what y actually equals. We just know we're supposed to do 15 minus y. Since we can't actually do it, that is my final answer to write 15 minus y. So x equals 15 minus y. Let's look again. Solve PQ equals x for Q. Once again, this little part right here tells me which variable I'm looking for. I'm looking to get Q by itself. So step one, locate Q in the equation. Well, that's pretty easy. Q is right here. Step two, identify the operations that are happening or being applied to Q. Well, it's being multiplied by P. Step three, use the inverse operations. So since Q is multiplied by P, I'm going to divide both sides by P to undo the multiplication. So as usual, I'm going to divide into two equal parts, left and right side of the equal sign. And to get Q by itself, I'm going to divide by P right here, divide by P right here. These two P's are going to cancel out. And I'm still going to have Q left on this side. And on the other side, I need to do x divided by p, which I have no idea what that is because I don't know what x equals and I don't know what p equals. So that is actually my answer. My answer is x divided by p since I can't actually do it. So the answer to this problem is q equals x divided by p. Here's your third example. In your third example, it says solve 5 minus b equals 2t for t. Remember, this part tells me which variable I'm trying to isolate. So step one, locate t in the equation. So here it is right here this time. It's on the right side of the equal sign. So there's my t. Step two, ask yourself what's happening to t? What operation? Well, I can see this means 2 times t. So for step three, since t is multiplied by 2, I'm going to divide both sides by 2 to undo the multiplication. So dividing my problem by the equal sign, I'm going to divide by 2 over here to get this 2 to cancel out so that the t, which was the question, is now by itself. And I also have to divide this side by 2. Notice I'm not just dividing the 5 or not just the b. I have to divide the whole side by 2. So when I continue on, I notice that my 2's canceled, so I still have t left over here. And on the right-hand side, I don't even know what 5 minus b equals because I don't know what b is. So there's no way I can divide it by 2. So my final answer is 5 minus b divided by 2. Notice I'm not actually getting any of my original things to go away. I had 5 minus b and 2 and t, and I still have a 5 minus b and a 2 and a t. I've just rearranged them to isolate whichever one they ask me to isolate. So I rearranged this to isolate the t. Now, this is a tricky question. On this one, I'm being asked to solve for v, and v is actually in the denominator. So the first thing I'm going to do is locate v, and I notice it's in the denominator. The second thing I'm supposed to do is step 2, is to say what's happening to v. But in this case, v is actually seems like it's the happening thing. I'm doing m divided by v. So the thing that's happening is dividing by v. But I want to get v by itself. So this is going to take an extra step. I first need to get v out from the denominator. So to get rid of divide by v, I'm actually going to multiply by v on both sides. These v's will cancel, leaving me with m. But on the other side, since I don't know what v or d equal, I'm going to have d times v, or you could put v times d on the left side. Now I have m by itself, but this question didn't ask me to get m by itself. It asked me to get v by itself. Well, I had to get v out of the bottom of the denominator. You can't just leave it sitting there by itself. So I had to get v out of the bottom. Now I say, what's still happening to v? It's being multiplied by d. So in order to cancel out that d, I'm going to divide by d on both sides. Now when I divide by d, v is by itself. And on the right side, since I don't know what m and d actually equal, that is my answer, m divided by d. We're going to try some more. While I'm looking at these, I notice that this one's asking me to get x by itself. So I say, well, what's happening to x? X is being multiplied by a. So I'm going to divide by a, cancel what can cancel, and I get x equals 7 divided by a. On this problem, it says solve for p. So I ask myself, what's happening with p? Well, there's an 8, and this is a positive 8 that's being added to p. In order to get that positive 8 to go away, I'm going to subtract 8, which means I have to go to the other side of the equal sign, subtract 8 over there. 8 minus 8 cancels, leaving me with p. And once again, since I do not know what w equals, I can't just subtract 8 from it. So I actually write that down, that my answer is w minus 8. All right, 2 more examples. This one says solve for m. First job is to figure out where m is. M is on the right side of the equal sign. It's multiplied by c to the second power. So how do I get rid of multiply? Divide. So I'm going to divide by c to the second power on both sides of the equal sign. When I do it on the right-hand side, this c over 2 cancels with c over 2. And I am left with m. But on the right-hand side, I don't know what E is. I don't know what C is. So my answer is actually E divided by C to the second power. Last example, solve for T. First, where is T? It's on the right-hand side. It's being multiplied by r. The inverse of multiply is divide. So I'm going to divide by r on both sides of the equal sign. Divide by r, divide by r. On the right-hand side, the r's cancel, leaving me with t, which is what I wanted. I wanted to solve for t. So equals t. And on the left side, d divided by r. Yep, I don't know what d is. I don't know what r is. So my answer is d divided by r.